Hello everyone, I welcome you all to today's session. This is yet another session in the series wherein we are picking up specific concepts, specific topics, specific tricks and discussing them, all right, in this short videos. Now today's session will be about learning how to compare given fractions, what are the different approaches that are available. Of course, we will not be covering all the approaches because there are plenty of approaches, some really basic, some slightly advanced. I plan on taking up 2 to 3 approaches today. So please pay attention. Also, before I continue with the video, I want you to take your attention to the fact that in our YouTube channel, we have videos of different types, different topics, different questions have been covered of previous CAT exams, right? CAT level questions have been covered. Please do check them out, right? And if you like our content, please do subscribe, share it amongst your student community in your community. I'm sure you would be benefited a lot from our videos. Let's get started. So today's class is about how do we compare fractions. So without going for the concepts and all, I would straight away go for the questions. We will try to understand how can we solve such questions. Let's start with the first one. So the question is, there are 3 different fractions given to us, A, B and C, and then he's asking us which is the largest. Now look at the fractions that we have, 24 by 121, this is A, 37 by 186, this is B, and 22 by 111. So one small observation that we can make while comparing the fractions is, if you have several fractions given, A by B, C by D, E by F, so on, you have several fractions given wherein you notice that numerators are all constant, they are all same suppose. If numerators are all same, can we say wherever the denominator is the smallest, that corresponding fraction, that particular fraction should be highest in the value? Similarly, if you notice that for a group of fractions, if denominators are constant, then we may say wherever in whatever fraction the numerator is the highest, the corresponding fraction is also going to be the highest. Correct? Now, the third point. We know that whenever you take any fraction, suppose x by y, and here if you increase the numerator but you keep the denominator constant and this increase is positive, suppose this delta that I am writing here is positive, you increase only the numerator and keep the denominator positive, the constant, then can we say the new fraction is definitely bigger than the old fraction? It will increase in value. Whereas if you increase the denominator but keep the numerator constant, then can I say the new fraction will be smaller, because denominator grows now, will be smaller than the original fraction. If you increase the denominator and numerator by some values, different values, delta 1, delta 2, then what can we say about the comparison, which will be bigger, which will be smaller? It would be hard to say, because on account of delta 1, the fraction should increase because numerator is increasing, but on account of delta 2, the fraction should decrease because denominator is increasing. So delta 1 and delta 2 will be actually pulling each other down. So this will try to increase the fraction, this will try to decrease the fraction. Then what do we do in this case? We generally will be confused. We will talk about this case also today. These are some basic cases and this is slightly advanced. We shall talk about this one also. But anyways, before we do this, let's get back to this problem. Now if you notice one small point here, 24 by 121, 37 by 185, 22 by 111, if you notice, each fraction, the denominator can I say is approximately 5 times of the numerator, please notice. So if you do 24 5 times, it will be 120, okay, plus 1 by 24. So if I divide the numerator and denominator by 24, suppose, what happens? 24 by 24 will be 1, 121 I can write as 120 plus 1, 120 by 24 will be 5 plus 1 by 24. So the first fraction, can I write it like this? I hope it's okay. Second fraction also, if you notice, 37 5 times is actually 185. So this is slightly more than 185. So again divide numerator and denominator by 37. So 37 by 37 is 1 by 186. I'll write it as 185 plus 1 by 37. So this will give us what? This will go 5 times 1 by 5 plus 1 by 37. And similarly here also 22 by 22 will be 1. 111 I can write as 110 plus 1 by 22. So 22 will go 5 times plus 1 by 22. Now this way what we have done essentially is we have now made our numerators constant. They are all 1. So the moment numerators are constant, wherever the denominator is the smallest, can I say that particular fraction will be the highest. We want the largest fraction. Wherever the denominator is the smallest, that will be our answer. Now where is it the smallest? Think about it. Now in the denominator again 5 plus 5 plus 5 plus is common everywhere. You ignore that. 1 by 24, 1 by 37, 1 by 22. 1 by 24, 1 by 37, 1 by 22. Which is the smallest value here? Can I say 1 by 37 is the smallest? Because denominator is the highest out of all. Hence, can I say overall, here in this case, denominator is the least. Please note, we are not doing any exact calculations for this. We are just observing the movement in the numerator, denominator, and based on that, we are trying to give our answer, right, to a large extent. Denominator is the least. Hence, can I say which fraction will be largest? I may say option choice B. So 37 by 186, we may say would be the largest fraction. So this is one of the ways of comparing the fractions by making either the numerators equal or the denominators equal, depending on whatever case is feasible for us. I hope we are clear with this. There are some other cases, we'll also take them up. Look at the second problem. Which is a smaller one between these two? Okay. So 317 by 331. 437 by 451. Now notice, here also dividing the numerator denominator by 317. What does it make it? 317 by 317 is 1. 331 by 317, can I write it as 317 plus 14 by 317? Exactly like the previous problem. So this will be 1. So 1 by 1 plus 14 by 317. Similarly, can I write the second fraction as, this will be 437 by 437, 1. 451 can write as 437 plus 14 by 437. So this will be 1. 1 plus 14 by 437. Yet again, we were able to write the two fractions in terms of equal numerators. Numerators are equal, 1 and 1. So whenever the numerators are equal, I want the smaller fraction, right? So can I say wherever the denominator is larger, that particular fraction will be smaller. Now where is it larger? 1 plus is common. Ignore that. 14 by 317, 14 by 437. Can I say definitely 14 by 317, this denominator will be larger, because the denominator of this fraction 317 is lesser than denominator of this fraction. This is larger, and hence can I say overall this fraction, which is A, is going to be the smaller one out here. So which is a smaller one? I'll say A is a smaller one, following a similar process. However, let me also teach you one more trick here. Now look at the trick, the point. The trick is, in case of proper fractions, if the difference between numerator and denominator is constant, in case of proper fractions where the difference between numerator and denominator is constant, the fraction with larger numerator will be higher, fraction with smaller numerator will be smaller. Observe, here what is the difference between numerator and denominator? It is 14. What about here? It is 14. And both are proper fractions, less than 1, they are proper fractions. Hence we can say directly, wherever the numerator is a smaller one, that fraction will also be smaller. So without any such calculations, any such simplifications, we can directly say our answer should be A. So this is a small rule. I'll just repeat the rule. You may note it down. The rule is, in case of proper fractions where the difference between numerator and denominator is constant, the fraction with higher numerator will be larger and smaller numerator will be the smaller one, smaller fraction. So relationship will now be dependent on basically the size of the numerator whenever the difference is constant. So this is second point, second question. I have one more question. Let us also try to do this. So this is slightly bigger one, right? Which is the greater one? So we have to find out which fraction is the bigger of the two. So let's see which approach can we use here. So 1256 by 7725 of the first fraction. 1540 by 9269. Now before I continue with this question, I would like you to go back. Please note here, we said if numerator increases, fraction will increase if denominator is constant. If denominator increases, fraction will decrease if numerator is constant. If both numerator and denominator increase, then we will not be certain about the movement of the fraction, whether it will go up or down, because we don't know what the values of delta 1 and delta 2 are. However, can I say one thing here, logically speaking? Now, can I say if numerator increases faster or higher than the denominator, can I say numerator's influence will be more? Example, suppose from here to here, numerator is growing by 15%. And from here to here, suppose denominator is growing by 12%. Both are increasing, right? Both are delta 1, delta 2 are positive, but numerator is increasing faster. So if numerator increases faster, can we say the fractional value should be pushed up? Because the nature of the numerator is it will increase the value of the fraction. Nature of the denominator is it will decrease the value of the fraction. So whenever numerator increases at a faster rate, can I say the fractional value should increase naturally, right? Isko, you can probably remember it as, observe, you have first fraction, second fraction. Suppose the numerator is changing by p% increase, denominator is q% increase. Case 1, if p is greater than q, that means numerator is growing faster than the denominator, then the fraction value should increase. Then we may say that fraction value should increase means x1 by y1 should be less than, or wahi, if at all you do the opposite, if p is less than q, that means denominator is increasing faster than the numerator, then x1 by y1, the value will be reduced, will be bigger than x2 by y2. So now if you apply similar process here, let's see what happens. Let's see what is the value of p here and q here, right? Approximately. What is p? Percentage change in numerator. How much is numerator changing? Please note. So 56 is becoming 40. So it will be 84. It will be 1340, 284. 284 it is, right? So 284 upon 1256. 284 upon 1256. How much will this be? We could probably simplify this. I think we can. Let's see. So how much will this be? We can cancel out some common factors here. So maybe 4. So it will be 71 upon, and this will be 314. 71 upon 314, right? Now 71 upon 314 is how much? Approximately in percentage terms. If you try to calculate the percentage value, or let's leave it at this. What is happening to denominator? Let's notice. From here to here, the denominator is growing by how much? 7725. So it's going to be 44 and 1544. 1544, right? On 7725. Okay. Now let's take 10% of this value. It's 772.5. Now what will be 20% of this value? Twice of this. So it's going to be 1540. 1545, right? Exactly 1545, I believe, right? 770 is 1540, 2.5 is 5, 1545, exactly 1545. So can I say the percentage increase in denominator is slightly, very small, slightly less than 20%. Had it been 1545, then it will be exactly 20%. Right now, can I say this will be very, very close to 20%, but slightly less than that. We don't know the exact value of the change in denominator, but we know it's slightly less than 20%. Now observe, what can we say about numerator here? 71 by 314, if you look at it, I'll not try to calculate it, but observe, if I take 10% of the denominator, 31.4, so what will be 20%? 62.8, clearly this is more than 20%. So that means numerator is growing at more than 20%, I don't know the value, denominator is growing at less than 20%, hence can I say for this particular set of fractions, P is greater than Q. And if P is greater than Q, the first fraction will be less than the second fraction. So this way, without any direct calculation, simplifications, alright, we could get to our answer by simply checking the percentage change in numerators and percentage change in denominator. I hope we are clear with this also. This is also a very, very important technique that we have when it comes to comparison of fractions. So with that question, we have come to the end of the video today. I hope you have found it to be useful. Please keep practicing it. On that note, let me end the session here. Thank you and all the very best.